like to do with you guys today is just sort of review quickly through this book on what we've learned. I'm going to give you lots of time to work today, lots of time to practice. If you need to work on the lab, then we can do that too. Same thing with tomorrow. I'm actually taking a couple students into Winnipeg, so I won't be here tomorrow. So you'll have a big, giant work period tomorrow as well. I'm not sure. Those of you that are away, I'll make sure you guys have all the handouts before the end of the day. Okay? This won't take too long. Okay, so you're going to have lots of time today. So, just quickly here, if you want to just sit back and relax until I get to a certain point, and then you'll need your booklet out. If you've got your booklet out, that's also great as well. Okay? So, just a reminder of a few things that we learned yesterday. Average acceleration, remember that it is the slope of the VT graph. We're talking about velocity time graphs, graphs of velocity. And acceleration is the slope of those, okay? When you see the graphs on the test or in any sort of assignment, you need to make sure you know, is it a velocity time graph or is it a position time graph? Because it makes a huge difference, doesn't it? Right? So number one, I would recommend you even just stop and you circle. Okay, yeah, velocity, got it, right? So acceleration is the slope of the VT graph, okay? And we spent quite a bit of time going through all that kind of stuff, okay? Then we got into like this kind of stuff, when's it slowing down, when's it speeding up, you're going to need to know that. Then we talked about displacement. Displacement on a VT graph is calculated by finding the area. Okay, the area. And we spent some time going through that type of thing. Displacement is the area on the VT graph. If the graph is above the y-axis, the x-axis, sorry, then it's positive displacement. If it's below, that's when the velocity is negative, which means it's moving backwards and you have negative displacement. Okay, and we went through a few pages on that. And then the last little bit here, then we did average velocity. Remember, average velocity is the displacement over the time, and the displacement has to be found by finding the area. Okay, and then I quickly went through instantaneous velocity. We were sort of getting near the end, so that's why I wanted to make sure I showed you this. Instantaneous velocity, because it's a velocity time graph, how do you find the instantaneous velocity? It's easy, you just read it off the graph. It's a graph of velocity, so it's easy to find. Okay? And then the last one, instantaneous acceleration. Again, acceleration is the slope, and so you find the slope of the line. If it's a straight line, you find slope. If it's a curved line, you're going to have to draw a tangent line. Okay? So that's all the stuff that we sort of learned. And then at this point here, now you need that booklet out. Okay? You need this booklet out. These next 2 pages are your guide for the next 3 or 4 days, okay? And as I pointed out earlier, they're so important. I run them off again for my grade 12s. They are extremely important. They tell you how to handle everything there is to know about position time and velocity time graphs. Okay? So what I would recommend you do is have this out here. We'll make a couple notes here. The left-hand column is position time. Do you see where it says position time at the top? Does it say position time at the top on the next page? Yeah. Okay, you might want to highlight those if you have a highlighter or underline or star or whatever. So the left-hand column is how to handle a position time graph. So step number 1, when faced with a graph question, what kind of graph are we talking about? So if it is a position time graph and you are asked to find displacement, well, that's easy. D is delta x. It's final minus initial right off the graph. So what I'm talking about there is like where you go like, right? There's your final, there's your initial, right? You're just reading off a really, really, really poor graph. Let me try that again. Okay? You've got a graph that looks like this, right? There's your final position, that's your initial position. Again, this is a displacement time graph, right? You just take the position of the initial, you take the position of the final, and you subtract the 2. If you're asked to take a position time graph and to find average velocity, there's 2 possibilities. It could be straight. If it's a straight line graph, then you find the slope. If it's a curved line graph, then you draw a line between the points of interest. So what I'm talking about there is when it's curved, you draw this line. And I would highly recommend you draw that little picture right in there. That will be a visual aid for you. Okay, if it's a curved line graph, you draw a line between the points because we're talking about average velocity. Average velocity. If you're asked to find instantaneous velocity from a position time graph, you have two possibilities. It could be a straight line graph, in which case you don't draw a line, you just find the slope of the line. You find the slope of the line, right? We're talking about instantaneous velocity, slope at an instant. If it's a curved line graph, well then we're talking about what? Instantaneous velocity. Again, we're talking about instantaneous slope. So you have to draw a tangent line. And I think those pictures will help you. Okay? So if you come to me with a question, the first thing I'm going to do is I'm going to direct you to these two pages, and I'm going to say, show me what question is being asked, and then I'll show you where to find the answer. Okay? You have the answers here. Now, if I give you a position time graph and I ask you to find average acceleration, it can't be done. That's not entirely true. You would have to create a VT graph first. Right? If you created a VT graph from your position time graph, then you could get the average acceleration. Well, maybe only in, extreme circumstances. Maybe in a bonus kind of enrichment kind of activity. Okay? Same thing with instantaneous acceleration, same thing. You would have to have a VT graph to do that. Okay? All right. Now, if we go back one page, right-hand column, velocity time graphs. Okay? So highlight that again, or underline, or something or other. Okay? If I give you a velocity time graph, these are all the things you can do with it. You can find displacement. How do you find displacement? The area between the VT graph and the time coordinate. What I mean there is the x-axis. Okay, you divide the area into rectangles and triangles so that the delta x equals area of all the rectangles and triangles. The area above is positive, and area below is negative. If I ask you to find average velocity, then the first thing you do is find the displacement using the area, and then use v bar equals d over t. If I ask you to find instantaneous velocity, you smile because that's the easiest one. You just read it directly off the graph. And if I give you a VT graph and I ask you to find average acceleration, here's where you've got two possibilities. It could be a straight line graph, and you simply find the slope. If it's a curved line graph, then you draw a line between the two endpoints and find the slope of that line. Okay, that's for average acceleration. It's really important that you take your time and read the question carefully and know what the question is, right? You might know how to do it, you might just answer the wrong question, really, right? What's 2 plus 2? Blue. Right? You've answered the wrong question. You know the answer, you just answered the wrong thing, okay? Make sure you know what the question is. Instantaneous acceleration, again, you're talking about slope at an instant. If it's a straight line graph, easy enough, find the slope of the line. And if you're given a velocity time graph and you've got a curved line graph and you're trying to find instantaneous acceleration, well then we're talking about slope at an instant, right? And then we are talking about the tangent line. Tangent line. That is all you need to know in a nutshell. Well, more than a nutshell. Maybe a coconut shell. Okay, there are, I believe, 4 graphs. 1, 2, 3, 4. Oh no, I'm wrong. 5. There are 5 graphs. Okay, and they are all velocity time graphs because we've done the position time ones already, right? I'm giving you the rest of this period to work on that. The answers are on the back. I've gone through them many times. The answers are now correct. Okay, I'm 99.9% sure. Okay, if you need some time to work on your lab, you can do that. I'm here today if you want some help with the lab. Okay, and then I'll hand out the hand-in assignment to those people that are away later in the period, and those of you will get it tomorrow that are here. Any questions of what to do kind of thing? No? Good?